Today in this session we will solve some numericals based on Carnot cycle. So let us see numericals one by one. I have collected numerous numericals at different types. So we will see the process. Calculate the maximum efficiency of a Carnot engine operating between 373 Kelvin to 290 Kelvin. So we will use this formula, that is efficiency is equal to 1 minus temperature of the sink minus temperature of the source. So again substituting value, so T1 is nothing but the low temperature 290 and the high temperature 373. So if you solve it, you will get the answer, that is 0.22. So in terms of percentage, it will be 22%. So this is the answer. Second question, heat is supplied to the Carnot engine in 2 × 10⁻³ joule. How much useful work can be made by the engine working between the 290 to 373 Kelvin? So again we use efficiency is equal to total work done, okay, divided by the Q amount of heat absorbed. And this we can write 1 minus again T1 by T2, that is the sink by source of the temperature. So what is the total work done? So total work done will be, because how much is the useful work? So this is the useful work. So this is equal to Q absorbed multiplied by 1 minus T1 by T2. So on solving, Q is how much? Q is given here 2 × 10⁻³ and 1 minus 290 upon 373. So if you solve it, you will get 445 joule. An ideal gas is taken through a cyclic thermodynamic process through a 4-step. The amount of heat involved in these steps are Q1 equal to 5960 joule and Q2 is equal to minus 5585 joules. Q2 minus, this is the heat given by the system. Q3 is again minus 2980 joule and Q4 is 3645 joule correspondingly. Similarly, work done W1 is given, that is the minus 2200 joule and W2 is 825 joule, W3 is 1100 joule. To calculate the W4 and what is the efficiency of the cycle. So we know that Q plus W is equal to entire energy, and in cyclic process delta U is equal to 0 in cyclic process. So we will take total Q plus total W. So Q total plus W total will be equal to 0 for cyclic process. So we can write Q1 plus W1, and then again Q2 plus W2, and then again Q3 plus W3, and then again Q4 plus W4. This is equal to 0. Now substituting the value, this will be your 5960 minus 2200. This will be your minus 5. So you can see 5585 plus 825, you can see, and Q3 is minus 2980 and plus 1100, and again Q4 is 3645 for heat, and this is W4, and this is equal to 0. If you solve it, on solving you will get W4 equal to 765. Now we have to find efficiency. So efficiency is equal to 1 upon, that is the Q less, which is converted into the work done, and divide by the Q absorbed. So this is the formula that T1 is, Q is the heat loss by heat gain. So we can write 1 minus 5585 plus 2980, and this is the divide by 5960 plus 3645. So if you solve it, you will get 1.089. So and finally you will get 0.108. So this is the efficiency of this thermodynamic process. In a Carnot engine, when T2 is equal to 0 degree centigrade and T1 is 200 degrees centigrade, so efficiency will be eta 1, and when temperature is same, that is T1 is 0 degrees centigrade and T2 is 200 degrees centigrade. So what is the efficiency of this eta 2? So we have to find out what is the eta, this eta 1 by the eta 2. So for eta 1, this is given 1 minus 0 degree centigrade can be written as the 273 upon, this is the 473. So we can write, so this will be your how much. So if you solve it, you will get 200 divided by 473, and for second eta 2 will be how much, 1 upon this will be your 0 degree centigrade. So we can write this is your again 200 degree centigrade, T2 is there, so we can write this will be your 73 divided by 273. So if you solve it, you will get again 200 divided by 273. So this is your minus 200 degree centigrade, make it correction, minus 200 degree centigrade. So now we have to take eta 1 by eta 2. So eta 1 by eta 2 will be your 273. So this is 273 will come up and divide by 473. So on solving, you will get answer 577. So this is the efficiency, ratio efficiency of these two with different temperature. For which combination of the working temperature the efficiency of the Carnot engine is highest? So we have four temperature, 80, 60, 180 and 60, 40, 40, 20. So we have to check it out in the denominator, which will be the highest will be the least efficient, the denominator which will be the lowest, which will be having the least efficiency. We have to take the ratio basically. This is the T1 by T2 should be least. So let's just we find out for A. If you take it, so A will be your 1 minus 60 upon 80. So you will get the ratio 1 minus 3 upon 4. So this is 1 by 4. So B will be your 1 minus 80 upon 100. So again this will come up 1 minus this is your 20 upon 100. So you will get answer here. So no, this is 20, so you will 1 by 5. And again if you say C, 1 minus 40 upon 60. So you will get here 1 minus 4 by 6, that is the 62 by 3. So 2 by 6 will be nothing but 1 by 3. And second case is 1 minus 20 upon 40. So this will be nothing but the half. So now if you compare it, so this is the half, means this will be your 50%. Remaining will be less than 50%. So efficiency is highest only in this case. An ideal heat engine working between T1 T2 has a efficiency eta, and what is the new efficiency of both the source and sink when the temperature is doubled. So in this case, when temperature is doubled, CC temperature is doubled, so definitely what happens, if temperature T1 and T2 is doubled, so definitely what will happen, the efficiency will be also double. So answer is answer. What will be the new efficiency? New efficiency will be that it will be also doubled when the source and sink is temperature are doubled. Efficiency of a Carnot engine is 50% when temperature of outlet is 500 Kelvin. In order to increase the efficiency up to 60%, keeping temperature of intake the same, what is the temperature of outlet? So efficiency is again 50%, means 50% means 50 by 100, and this we can write 1 upon 500 divided by the T2 temperature. This is the your temperature of the outlet. You have to find the temperature of T2. So on finding T2, you will get there T2 is equal to how much? 1000 Kelvin. Now second, in order to increase the efficiency up to 60%, 60% means it will become your 60 upon 100. So again 1 minus T1 upon this is the T2 temperature 1000. So when you get 1000, so on solving you will get T1 is equal to 400 Kelvin. So this is the temperature of the outlet when this temperature becomes your 1000, T2 becomes 1000. A Carnot engine has 3 into 10 power 6 calorie of heat from a reservoir at 627 degrees centigrade and gives it to the sink at 27 degrees centigrade. What is the work done by the engine? So again, efficiency is equal to work done by the Q absorbed. That is nothing but this is the T1 by T2. So we can write work done is again given here by heat absorbed this much, and work done we have to find out. So work done by heat is equal to 3 into 10 power 6 and temperature 1 minus 300 by, this is your 900. So if you solve it, so this will give you work done by 3 into 10 power 6 is equal to 9. So this will be 1 by 3. So this will give 2 upon 3. So work will be 2 by 3. So this will be cancelled. So you will get only 10 power 6 into 2. So this is the total calorie. Temperature of the sink of the Carnot engine is 27 degrees centigrade. So this is the 27 degrees centigrade. The efficiency of the engine is 25%. Then what is the temperature of the source? So we can write, so this is your efficiency is 25 divided by 100, and this is equal to 1 minus 300 by T2. So this will give you your, if you solve it, so 1 by 4 is equal to 1 by 300 by T2, or we can say 300 by T2 is equal to 3 upon 4. So T2 will be how much? 400 Kelvin or 127 degree centigrade. If you subtracting by 273, so you will get this much temperature. A Carnot engine whose low temperature reservoir is at 7 degrees centigrade and has an efficiency of 50%. It is, so this will be your 50 by 100 is equal to 1 minus 280 by T2. So if you solve it, on solving you will get T2 is equal to 560 Kelvin, because this will be half. Again case 2 will be your, this is your case 1 of 50%. So case 2 is 70%. 70 upon 100 is equal to 1 minus 280 upon T2 plus X, where X is the enhanced temperature. So this will be your, so this is 7 by 10. So we create 1 by 7 by 10 is equal to 280 plus T2 plus X. So T2 is this one 560. So we create 280 plus 560 plus X. So again if you solve it, 560 plus X is equal to nothing, 2800 by 3. So this is nothing but the 3 by 10. So this is 2800 by 3. So again we can solve. X is equal to 2800 by 3 minus 560. So on solving you will get 373 Kelvin. So this is the answer of this question.